Looking at the next example, it tells us that we have MO and PR. So there's MO, there's PR, and it tells us that they are parallel lines. So there's those lines, there's that transversal. It tells us that MNQ is 113 degrees. What is the measure of PQS? So we're looking at how that angle right there is related to that angle right there. Well, they're both to the left of the transversal. They're both below the transversal. So those are going to be corresponding. They're in the same spot. They're both corresponding angles. And if we look back at our corresponding angle postulate, it tells us that those two angles are going to be congruent. So we're looking at angle MNQ, and we want to show that it's congruent to angle PQS. So MNQ, I've got to switch it to equals first. So MNQ is 113 degrees, is going to be equal to angle PQS. There we go. Looking at the next one, we've got DF and GI are parallel lines. So there's DF, there's GI, and we're saying that those are going to be parallel. So there's our transversal cutting through right there. It tells us that FEC is 62 degrees. What is the measure of IHJ? So FEC and IHJ, well, they're both on the same side of the transversal. They're both below. So same side, remember, means consecutive. So if we're looking at consecutive, and here's the parallel lines, so that determines what's inside and what's outside. They're both outside. So we've got consecutive exterior angles. And if we look back at our consecutive exterior angle theorem, it tells us that those angles are going to be supplementary. And remember, supplementary means two angles that add up to be 180 degrees. So listing the angles that we're working with, angle FEC and angle IHJ. And those two angles are going to add up to be 180 degrees. So FEC is 62 plus angle IHJ is the one we don't know, so I'm going to leave it the same, equal to 180. Subtract the 62 from both sides, and angle IHJ is going to be equal to 118 degrees. And then looking at the last one. And this one, it tells us CE and FH are parallel lines. So there's our CE, there's our FH. I'm going to show that they're parallel lines. There's our transversal. So they're telling us I work with HGI, and they're telling us it's 68.9 degrees. What is the measure of angle CDG? So we're looking at that angle and comparing it to that one. Well, if I'm looking, I have this angle on the outside and that angle on the inside. So the only one that'll work for that one would be corresponding angles. But in order for it to be a corresponding angle, it would have to be on the same side of the transversal, on the same side of the line. Now it is on the same side of the line. It's below the parallel lines, but it's not on the same side of the transversal. And this example is an example of a problem where you're going to have to use rules that I've taught you before in order to be able to use the rules in this lesson. So it doesn't follow any of our rules for two parallel lines with a transversal. But if it had talked about this angle and this angle, those would have been consecutive interior angles. Well, is there a way to know the value of this angle given this angle? How are this angle and that angle related? They're vertical angles. So I can say angle IGH. No, they used HGI, so I'll use HGI too. We can say angle HGI is equal to angle FGD. So that'll tell us HGI is 68.9 is equal to angle FGD. So now, if we're talking about this angle compared to, so FGD compared to angle CDG, we can say that they are consecutive interior angles. And we know, based on our rules that we have from today, those are supplementary. And remember, supplementary means two angles that add up to be 180 degrees. So if I do that, I'm going to write it below, angle FGD plus angle CDG is going to be equal to 180 degrees. FGD, we said right there, is going to be 68.9 plus angle CDG is going to be equal to 180. Subtract that 68.9 from both sides, and that'll tell us that angle CDG is going to be equal to 111.1. So you can see how it looks like there might not be a relationship, but using things that we know, we can have a relationship to exist. There is another way to solve this one. Instead of using vertical angles, you could have also used a linear pair right there, and then done 180 minus 68, and then done the alternate interior angles, and that would have also gotten you the 111.1. Try it out, see if it works. Looking at the next one, we've got GI and JL are parallel lines. So there's our GI, there's our JL, and they're telling us that those two lines are parallel to each other. So given two parallel lines in a transversal, they want us to show how LKM, which is 46.9, is related to and can give us the answer for angle GHF. So we're looking at that one right there. So LKM GHF. Well, they're both on the outside, and this one's on this side of the transversal, and that one's on the other. So if they're outside, we can say they're exterior, and they're on opposite sides of the transversal. Remember our word for opposite sides of the transversal are alternate exterior angles. And if we look back for our alternate exterior angle theorem, it tells us that they're going to be congruent. So angle LKM is going to be congruent to angle GHF. So angle LKM, we can say it's going to be equal to angle GHF. So LKM we know is 46.9, so that's going to tell us that angle GHF is going to be equal to 46.9. And that's how given two parallel lines and a transversal, that's how they could have you find values for those angles. Something else that they could do is they could, instead of just giving you numbers, they could give you algebraic expressions. So they could tell you like x plus 2 here, and then like 2x plus 3 here. And then you would set this equal to that. And that's why I've shown you how to set them up here. And that way, if you do get expressions where you have to solve, you just set them equal to each other, just like I did here, and then solve them out and get whatever the value is that you're looking for and plug it back in. Alrighty, guys. See you later.